Slideshow set up, current slide. All right, good afternoon. This is the math team reviews again, this time going over the inaugural Allomatic math tournament last Friday. Okay, was that right? Friday, yeah. Last Saturday. All right, start at the beginning.
Also,
okay.
We don't have the answers.
Yeah, we don't have answers, so I'll make things up. Okay, that makes it better. Okay, evaluate the limit. The limit as x approaches a of x cubed minus a cubed divided by x squared minus a squared. Okay? How would you begin?
Well, I always want to check and make sure that it's...
Absolutely.
Yeah.
And what happens when you do?
We plug it in and 0 over
0,
0.
0, which is an?
Indefinite form.
Yeah, or indeterminate form, either way you want to call it. Okay? Now, there's two ways you can approach this one. Okay? I think equally good and handy. What would be your suggestion?
I kind of want to see if I can't factor it.
That would be my suggestion too. So I'm going to leave off the limit thing. Let's just see if we can factor. What's the difference of two perfect cubes?
Oh, that's pretty gross, actually.
Okay.
It would be easier.
It'd be what?
It'd be like a binomial times a
Trinomial. Right. Do you remember what the binomial is? The cube root x minus a. That's it. Now, to get the trinomial, forget about x cubed minus a cubed. Look at the binomial. This is just a thing that works. There's no reasoning behind it. It just works. Square the first, x squared, opposite the product of the two.
So positive x plus a, or x minus
ax, right? And add the square of the last. Negative a squared is a squared. That's the second factor. You can always check it by multiplying through. It works. Okay, x cubed minus ax squared. This will give you, a plus ax squared. That gives you minus ax squared. This gives you a plus a squared x. This gives you a minus a squared x, and then minus a cubed. Yeah, so that works. Okay, the denominator. Right. Right. X minus a times x plus a. Those go away. Okay, now I think you can do it. Right. Yep. Try it and see. If it comes indeterminate, we'll try something else.
Plus 2a plus
No, not
2a. It'd be a squared. A squared plus a squared, right?
Plus.
A squared.
Yeah. So that's 3a squared over 2a equal 3a over 2. Right? 3a over 2 was number B. Okay? Got it? All right. That was number 1. This is number 2. Find F243 x given that f of x is equal to cosine x.
We did one like this that was similar to the last time.
Right.
So what we first did, we took a derivative.
Right.
And we took like.
And by the way, just I know you know it, but just for others listening, when you have it in parentheses here, that means derivative. That's the 243rd derivative of f. If that was 243, that means that function raised to that number of powers. Okay. But in parentheses, that means that derivative. So f prime of x would be negative sine x. Okay. F double prime of x, negative cosine x. F triple prime of x equals sine x. F to the fourth, I'm going to write it that way, x is equal to cosine x.
So we see that every fourth
Derivative.
it comes back around.
Right.
So we can divide
243 by 4.
right?
And that would be
60.
and yeah, and okay. So the 240th would be cosine 241st minus sine 242nd, 243rd sine.
240, 241, 242, 243, and that gives you a positive sign.
Yeah. And that is A on here.
Don't mind the little marks.
Okay. All righty. Okay. I think maybe I should start a clean page, okay? Okay. Whoops. I did the wrong button. Okay, got it. Number 3. Find the intervals on which
Go back.
my pen isn't working. Now it is. Find the intervals on which f of x is equal to x to the fourth minus 6x squared minus 6 is increasing. Okay? So, how are we going to do that one? Ah, sounds like a capital idea. Okay, f prime of x is going to be 4x cubed minus 12x. Done. What do we do with that derivative?
Guess we got to find out where it's positive.
Right.
What does x equal to make it positive?
Okay. So probably a pretty good thing to do is find out where it's 0.
Right.
Okay.
So you found the critical point, right?
Yes. Okay. And what would that tell us?
We would need to factor it.
Okay. And why would that factor?
How pull 4x
4x times.
x squared minus 3.
Okay.
So x equals 0.
X equals 0 is a 0. Critical point.
Square root of 3 is
Okay. Square root of 3 is a critical point. Or
negative.
negative
Plus or
square root of 3. Plus or minus square root of 3. Those are your 3 critical points. Okay. Now,
We need to test a little to the left and a little to the right of each one.
stand up, sit down, fight, fight, fight. Yeah. Okay, got it. Okay. So,
little to the left.
all right, what's a little to the left of negative 3? Square root of negative 3,
Negative 4.
which
Negative
is,
3.
okay, how about square root of negative 4? That's a little to the left, which
So
is,
negative 2.
okay, negative 2. Plug in a negative 2 and see what you get. to the derivative. Yeah, no, derivative. If it's positive, it'll be increasing, negative, decreasing. Okay, what do you call the first one? Yeah, it'd be a negative 32, isn't it?
Oh, I forgot we were talking about negative 2.
Right. Plus
A negative, or positive,
24, so that's going to be negative.
negative.
So it's decreasing left of negative root 3. So let's pick something in between negative 3 and 0.
1.
All right, sounds good.
Negative 1.
Negative 1. F prime of negative 1 would be, this is less than 0, decreasing, okay?
Negative 4 plus 12. That would be positive.
So increasing. So I think we can say safely on the interval between negative root 3 and 0, it's increasing.
So that's 1.
Let's try 1. F prime of 1.
That would be 4 minus 12. That would be negative.
Okay. Decreasing. So that's less than 0. Okay.
And then we're going to try f prime of positive 2.
Yeah, sounds good to me.
32 minus 24, and that's positive.
Okay. So then between root 3 and infinity. All right, let's see if they have anything here. This was, I didn't number this. This is number 3. And that's between negative 3, 0, and root 3 and 0, and between root 3 and infinity, that's answer D. All right, good deal. Make sense?
Yes.
All right. Number 4. Suppose f of x is an odd function. Okay. Really strange bird. Okay.
Yes.
Which of the following is or are equivalent to
One of these.
the integral of minus a to a of f of x dx? Okay.
And that's all they get us.
That's all they give you.
Okay.
Now,
Okay, so the fact that it's odd.
here's an odd function. Yeah. How about that one? Isn't that odd enough?
I prefer the ones with this, but that works.
Yeah. Okay. Sine would work, you know, any of those. And if you did the integral from minus a to a, this would be a negative, that'll be a positive. Exactly the same. That's going to be a 0. And that answer 0 was I only. Little Roman numeral, little I only. This answer, 2 times the integral of 0 to a of f of x dx would have been correct if this would f of x would have been even. Okay. This one, the integral from minus a to a of f of minus x dx, that also would have been if it's even, because that's the same thing. F of an even function, f of minus x is equal to f of x. So that's the same as that. So that would have worked for even as well. It wouldn't have worked for odd because f of minus x for odd function is minus f of x. So that would have been, if this would have been the question, that would have been a correct answer there. Okay. But neither of those would work. Nothing would work except 0. Okay? Understood? Or question? Need it anymore? I just put a real simple one down there, but any one would work like that.
Yeah, because, well,
Right, exactly. If you want to do those, you could, yes. Of course, the,
high school teacher doing this all the time.
yeah, of course, the, what do they call it? Monitor might have thought, God's going into, no, never mind. Okay, that was number 4. Number 5. Let y equal 2x plus 1 squared. Find d2 by dx squared of y double prime over y prime. Oh my word. What a strange problem. But it may not be as strange as it seems. What's that?
Well, they do a couple of things here. They throw something at you that's weird, and they also don't put it in exactly the best
Format.
Yeah. They put it in format to make you feel uncomfortable.
Right. So what would you do first here?
Okay, so we're working with the y equals, but we want to find the d by dx and the y double prime over y, right?
Right.
Okay, so I would take a derivative.
Yes, y prime you got to have. And what is that?
Chain rule, so 2, 3, 4 times 2x plus 1 x.
Times the derivative of the inside, another 2. So that'd be 4 times 4x plus 1. Okay, which would be 8x plus 1. Right? 8x plus 4, sorry. Really doesn't matter. But yeah, 8x plus 4. Okay? Now, what will you do next? And by the way, for people listening in, I know you know it, what we did there, we took the power times the thing that gave you 2 times x plus 1 to the minus 1 power, 1 less than that, that would be the first power. But then by the chain rule, we have to take the derivative of the inside, which would just be another 2. So the 2 from the exponent and the 2 from the chain rule, that gave us our 4 times that, and then we multiply 3. So what's your y double prime? 8. Done. All right, so now what we do is write that fraction. Y double prime over y prime would be 8 over, let's go back to the first form, 4 times 2x plus 1. I like that one better because now I can divide out that. I'm just being lazy, really, really lazy. So this is 2 over 2x plus 1. That's what that thing is there. Our new function, right? Y double prime over y prime. Okay, I'm wanting to take a derivative of that, right? In fact, I'm going to do it twice. Excuse me, have you got a class in here? Okay, see, if they do, we need to move. I don't think so, but ask him. Okay, yeah. Okay, that's fine. If you want to. Doesn't bother me. I just thought maybe they had picked up with the second mini-term. Yeah. All right. What I suggest doing for taking a derivative, it's just my preference, is this. Write this as 2 times 2x plus 1 to the minus 1 power. Okay. Now I'm going to take a derivative of that and then take a second derivative of that. That's what it told us to do. So d by dx of this thing, 2 times 2x minus 1 plus 1 to the minus 1 power. What would that be?
It would be -4.
Okay, now you can't multiply the 2 times 2. Because this is in the numerator, that's in the denominator.
Oh.
Right. It's 2 times this thing. If that were just a parentheses there, yeah, you could, but not with the power there. Okay?
-2.
Okay. Yeah. -2 times Okay, you're doing the chain rule. Okay, that's perfectly good. In fact, a very good thing to do. Okay. -2 that was on the outside already.
Parentheses.
Yeah.
2.
2 from the chain rule. Is that where you got that one? Okay.
Parentheses. 2x plus 1 to the -2.
Okay.
Would it be too far-fetched to move? You see to take the parentheses around that 2 and move that one to the end?
Okay. This now is your -4. Is that what you were saying
Yeah, that's
before?
what I was saying
Oh,
before.
sorry. I thought you were
I
multiplying.
was like, I
Just
didn't
a-
know you couldn't do that.
No. That's perfectly fine. Okay, I just didn't know you were doing 2 steps at once.
Yeah.
Okay, and then this will be 2x plus 1 to the -2. Now, what were you asking it would be okay to do?
No,
Oh, that was it.
That was it.
Okay. So that's d by dx. Now we want to do that again, d2 by dx squared, which would have been taking the derivative of that. And that would be
16. 2x
2x
plus 1 to the -3.
okay.
You do the -2 times -4, which is 8.
Yeah, okay, so 16. Okay, this is equal to, I'm not writing the thing down, okay. 16 times 2x plus 1 to the -3. Now I think I go back and write that in more standard thing, 16 over 2x plus 1 cubed. One of those two answers should be it. 16 over 2x plus 1 cubed, number D,
Number D.
or letter D, or letter B. Okay.
What?
Let it be. Never mind.
Maybe not.
All right. Got that for 5?
Yep.
All right, number 6.
Sit there and power through these.
Let's let f of x, it's ugly x, equal to x cubed minus 9x minus 14. Find the point or points where f of x, f prime of x, and f double prime of x all coincide. We got f of x.
Right. So we need to find f prime and
F prime of x would be
3x
3x,
minus 9.
3x squared minus 9.
Squared minus 9.
Okay? And
Alright, f double prime of x would be 6x. And that's
6x. Success. Okay. Success.
6x.
All right. Now, where these coincide is looking for the value of x where all these will have the same value.
Well, y is always 6. Y is always 6 more than x for the double prime.
Okay, 6 times x, right? Okay, so these all have to be equal to each other, so I don't think it really matters which way you go here. I guess maybe easier to set the bottom two equal to each other. The point where 3x squared minus 9 is equal to 6x.
And then you subtract the 6x over and then set it equal to
Yes.
0.
3x squared minus 6x minus 9 equals 0.
Okay, I said we factor out a 3.
Let's do that first. 3 times x squared minus 2x minus 3 equals 0. Divide out the 3. Will that factor? Looks like it might. Be x times x plus and minus 3 and 1,
with the negative and 2 with the positive.
or 1 with the positive.
Or 1 with the positive.
Right. And I think that works, doesn't it? So you got two potential points, x equal -1 or x equal 3. Okay? Let's see if either one of those
Come up when you do double prime to f of x.
yeah, Let's see, what might be the easiest thing to do there?
I was saying the double prime with the original x.
That's what I think so too. So x cubed minus 9x minus 14 is equal to 6x. That will be the same as x cubed minus 15x minus 14 equals 0. Okay, let's plug in and see if either one of these works. X equal minus 1, that would be a minus 1 plus 15 minus 14 equals 0. If it weren't Alabama, I'd say bingo, that works. Okay, let's see if the other one works. 27 minus 45 minus 14, not going to be 0, right? So x equal negative 1. Now, what was the question? Find the points where that's true. The point would be negative 1, and we need to plug that in. No. That will give you what the second derivative is there. We want the point. This is your y value. Okay, so plug it in there. And that would be negative 1 plus 9 minus 14. Negative 15 plus 9 is negative 6. Negative 1, negative 6. D. Again, they like these, don't they? Do you like these?
No, I prefer A's.
Okay. All right. So that's number 6. All right. I do see a little mark by A.
We're not going to talk about it.
What's that?
So we're not going to talk about it.
Okay, not talking about it. I see nothing. Okay. This one requires a graph. And I think,
We have a graph page.
yeah, we do have a graph page. So what we'll do is go back to the graph page and see if we can get this to fit on here somehow. The graph below represents f of y is equal to f of x. Which of the following is true? We have 0, 3, 1/2, 2, 1.5, 1/2, 2, 0, 2.5 is awfully close to a half. It may not be exactly. 3.5 is very close to negative 1, but not quite. 4 seems to be exactly at negative 1. 4.5 is a little above that. And 5 seems to be somewhere above that. So here's, and by the way, negative 0.5 is at positive 4. Okay. Okay. So it seems to be a curve that's doing something like that. I may not have it exact, but something like that. All right. Now we need to, which of the following is true? F prime of 2 less than F of 2 less than F double prime of 2. So let's focus in on 2 here. That's right there. F of 2 we know is 0, right? Okay. F prime of 2 we know is negative, right? F double prime of 2, I'm pretty convinced that's positive. Why? concave up. Exactly.
But it's the derivative of the
Yeah.
first,
Yeah, it's the rate of change of your first derivative.
and since it's
And the first derivative was more negative on the left, less negative on the right. So, yeah. Yeah. So that I think is true. So we know little Roman numeral I is correct. Okay. Number 2, Roman numeral 2. Two i's. F of 2 less than F prime of 2, absolutely not. Because F of 2 is 0, F prime of 2 is negative. Can't be that one. Roman numeral 3. F double prime of 2 less than F prime of 2. Absolutely not. Okay, you don't have to go any further. Okay, the first one was on double 2 is F of 2, which is 0. I mean F of 2, which is 0, they say is less than F prime of 2, which we know is negative. Can't be. Not. So it's 1 only. And someone had a little mark by that. We'll talk about that one. Okay. All right. Good deal. What's that?
I said I wouldn't, because then they'll have any I missed.
Okay. Well, I've only mentioned the one you got right. That didn't sound right, did it? Okay. Let's see. I wasn't paying attention before. So you probably got many more of them right.
No,
Okay.
I don't know about that.
All right. We'll go.
We won't talk about that either.
Okay. We'll go to number 8.
There we go. That's what I'm talking about, right over the number.
Yeah, right. If F double prime of X is equal to F of X plus F prime of X, to which of the following is F fourth derivative of X equivalent?
See, and it was so easy because it was just substitution.
Yeah.
I just didn't make the connection.
Okay.
Because, yeah, you can go ahead. I'm not gonna.
All right. All right. Now, I guess,
That was my expression during the
yeah,
test.
I guess the first thing I would be tempted to do was do a F triple prime of X. Okay, and what would that be?
F
F prime
prime
of X,
plus
F
double prime.
double prime
And
of
see what
X.
you do is you plug in what you had at the beginning for F double prime.
Yes. Poor Richard, listening at home, didn't know that was coming, did you? All right. So now you want to plug in that?
Yeah.
We can. So this will also be equal to F prime of X plus F of X plus F prime of X, which would then be 2F prime of X plus F of X, right?
And then
F4 of X would then be going to here. Okay.
Plus F prime of X.
Yep.
Okay. And plug back in one last time.
Yes, and that would be 2 times F of X plus F prime of X plus F prime of X.
Distribute the 2's and add your F primes, you get 2F of X plus 3F prime of X.
2F of X plus 3F f prime x. Okay, let's see if that's an option here. 2f of x plus 3f prime of x. The ones you like. A's. You said you liked A's, right?
I got the right one.
Okay. But you said you liked it. You liked A's. Okay.
Yeah, Mr. Rossi nearly. For that. We were kind of going over it after lunch.
Right.
And...
All right. Okay.
Luckily, you're more contained. And after there.
Well, I may not be so keyed up. Okay. High strung, maybe. I don't know. Okay, number 9. Let f be a one-to-one function. Okay. With alpha 4 equal to 12. F prime of x greater than or equal to 2 for all x's less than 6. Which of the following is necessarily true? Okay. Number A.
So, I kind of wanted to draw a graph.
Okay.
Just to kind of
Probably would be okay. It says here f of 0 is greater than or equal to 20. Okay. Now f prime of x is greater than 2 for all x's less than 6. Okay. Now, f is 1-to-1, right? Alpha 4 is 12. But the derivative of all the x's less than 6 is greater than 2. Okay? So that means f of 0 has to be less than 12. Because the derivative, f of 0, has got to be a plus 2. And to be 1-to-1, it can't ever be negative, because it has to be strictly increasing, at least doubling, and it couldn't possibly be greater than 20. Okay, let's draw the graph. Sorry, wrong way. Let's clear that. Okay. Alpha 4, 1, 2, 3, 4 is 12. 2, 4, 6, 8, 10, 12. Okay. Okay. It's 1-to-1, and the first derivative is greater than 2, greater than or equal to 2 for all x's less than 6. So here the slope is at least that high, and it's a 1-to-1 function. Okay, so that means f of 0 has to be less than 12, because it's a 1-to-1 function, monotonic, so increasing everywhere. It has to be less, in fact, the least it could be.
Because you have a point below 20 that's less than 4, it's 4 units away from.
Right.
Yeah, that makes sense.
Okay.
Kind of weird to word it.
Yeah, exactly. Exactly. So A is out. Okay. B. And A, by the way, was that f of 0 is greater than or equals to 20. Okay. B. f of 0 is less than or equal to 0. I think it's got to be. Because this slope for everything here can't be any
Can't be
less than 2. Got to be greater than or equal to 2. So if it was 2,
if it was 2, it would be going down 2 over 2, down 2 over 2.
yeah. Well, wait a minute. Remember, I've got a scale here.
Yeah, so it'd be 10.
And this scale is wacko. 2, 4, 6, 8, 10.
It could be 4.
Okay, it could be. That's why I just said my scale is off because I was putting it in. This is a slope of 2. Yes, it could be 4. That's if all of them. It may not be 2, maybe something less than 2, but it could be anywhere from 0 to 2. Okay, so this is a possibility. It's not. You can't say for sure. It says it's necessarily true. This may be true, but not necessarily. It could be as high as 4. Can't be any greater than 4, but it could be anything less than 4. This is a slope of 2.
It could have a bigger slope.
Yes, exactly. Right. Okay. So B is a maybe, but not necessarily. So I think it's out too. C, f of 0 is less than or equal to 4. That is the winner. Okay. Let's see what the other is. F of 0, this is D, is greater than or equal to 0. It could be, but doesn't have to be. So I think your winner has to be C. Okay. And I believe somebody got that.
It happens every once.
1 out of 5 chance, huh? Oh, never mind, I didn't say that. Okay.
Like I said, I would be extremely happy if I made it 10.
I think you did better than that, just looking at it. All right. I haven't been paying close attention, though.
That's why I'm writing down the answers so I can find out myself.
Right, okay. And this is number, let's see, erase all this. But I don't think I need this graph. I think I go to this one, yeah, and erase all that. Okay, number 10. Let y equal g of f of x. Whoa. Y equal g of f of x, f of g of x. I guess that's multiplied. Okay, I assume that's a multiplication in there.
Because I think I got this one right.
Yeah, and it says find y prime. Y prime would be, well, obviously you've got a, huh?
It's a product rule.
Yes, it's a product rule with a chain rule involved on both sides. So, which way you want to go?
Alright, so we'll start off with the derivative of g of f.
Okay, so that'd be g prime of f of x
With times
f prime of x,
plus f.
okay, that's multiplied by f of g of x, right? Derivative of the first times the second.
I said plus and times.
Yeah, okay. Okay. Plus,
F prime.
okay, I'll do that.
I always like to put what I'm taking the derivative.
Right, that's fine. You do everything. No, I mean, okay. F prime of g of x
Times g prime.
g prime of x times
G of f.
g of f of x.
And that's what I got, I'm pretty sure.
Okay, and let's see if we can find that answer. G prime of f of x, A's wrong. B, f prime of g of x, g prime of x, times g of f of x, right so far, plus g prime of f of x times, okay, g prime of f of x times f prime of x times f of g of x.
That's it.
Yes, and you got it. Good deal.
That one I remember. I like that one.
Yeah.
It felt-
Okay. Let's see if we can get 11 on this page. It looks short, but I don't know if it is. Find the tangent line to the graph given by x squared minus 2y cubed equals 7 at the point 9, 1. Okay, before I do anything else, I want to make sure that point is on that graph. When x is equal to 9, this will be 81 minus 2. That can't be right.
Is there
X minus 2 y cubed, that could be right, but x squared, that point's not even on it. Is it? So
is there a thing that
there's a none of these.
I didn't select that, but
No.
I'm pretty sure I got this wrong. Because what I think what I did, but yeah, I don't think it's on the thing.
Either they mistyped this one or they or this was a none of these, because that point is not on that graph. Because when x is equal to 9, y can't be equal to 1. That'd be 81 minus 2 is not equal to 7. So,
And what was the directions one more time?
so let's find the tangent line to the graph given by this equation at the point 9, 1. And this graph doesn't go through the point 9, 1. So how can you find the tangent point at it?
Does the tangent line go through 9, 1?
Possibly, but not on the graph it doesn't. Okay. So where do you put it at when x equal, no, I don't know. I mean,
Find the tangent line.
yeah. This is a none of these, but whether they meant it to be that or not. If that were a valid point, let's see if we can find one.
You would have to find the equation of the tangent line.
Yeah, and how would you do that?
I won't talk about it. It would have to, and then you'd have to find where it intersects the graph.
Right. Well, no. Okay. Let's first find the slope of the tangent line.
Which is the derivative.
Derivative, which is y prime, right?
Right.
So the derivative of this thing would be 2x
minus 6y dy.
6y squared
6y squared dy.
dy dx
dx.
is equal to
Yeah, that's it. Y equals 0.
0. Okay? So then you could say that 2x is equal to 6y squared. I'm just going to put y prime as easy to write. Okay?
And then,
And then,
fit there, 18 equals, nope. It's not equal 6.
yeah, y prime would be equal to 2x over 6y squared, right?
Yeah.
And that would be, so if that were the point, which it isn't, that would be 18 over 6. So that would be 3. So your y prime would equal to 3. Okay? If that point were on the curve, that would be your slope. But it's not. Okay? I don't think. Okay? So there's your slope. And then you would do the point slope formula. Y minus y1 is equal to m, this is your m, times x minus x1. And that would be y minus 1 is equal to 3 times x minus 9. And that would be y minus 1 is equal to 3x minus 27. Add 1 to both sides, and you get y is equal to 3x minus 26. And that was an answer. And it was an answer someone chose. But the problem is...
Did I really choose that?
Yes, you did. So you did the problem right, but you assumed they had it on the point. And I always am a cynic and check to make sure the point's on the curve. And it's not. But if they did a mistype, then they may think that's the right answer. I don't know. And you don't have a key, you said.
Dr. Thomas might have one.
Okay.
But she doesn't get out of class until this
Right.
is over. So
Right.
we'll double check on that.
All right.
And that was, what answer
That-
was that?
That answer was C. This answer was C.
And you're pretty sure it was none of these, unless it was in this time.
Yeah,
So that'd be E, right?
E. Right.
Either
I
E
think
or
the
C.
answer is E.
C for Cameron and E for Elder, right?
Huh?
I said C for Cameron, E for Elder, right?
Ah! Okay. Elder statesman, you might say. Okay. All right. Can I race?
Sure.
Okay, let's go to 12.
That'll make you feel better.
All right, nothing makes me feel better. Whoops, wrong answer. Okay, 12.
My favorite number.
Oh, really? Mine's 7. It's my birthday.
Well, see, mine is 12 because December 12th.
Is your birthday? 12/12.
And you know what time I was born?
12 noon or midnight?
Midnight.
On
12/11.
Huh? 12/11.
12/11.
Okay, just barely on the
So I
12th.
was probably breathing around.
Right. Okay. All right. Here's number 12. The graph below represents the position of an object moving horizontally on a straight path. Which of the following are true? Okay. It shows a point 0, 0. Shows a point 0.2, 1. If I use 0.2, I'm not going to get everything on here. They're going up to 3.6. 6, 7. So let's do this 0.6, 1.2, 1.8, 2.4, 3, 3.6. That's going to be my X scale. This is going to be compressed this way. Okay? And they're going up to 3.5 here. 1, 2, 3, 4, 5, 6, 7. So let's call this 1, 2, 3, 3.5. We're expanding the Y scale, well, yeah, and condensing the X scale. So this is going to look a lot different from this one does. 0, 0, 0.2 is going to be 0.5, let's see, 0.2 is going to be 1. So 0.2 is about a third of the way there. So I'm just going to guess right there. 0.4 I can't really tell. 0.6 is just going to be just a tad over 2. Okay, right about there, maybe, something like that. 0.8 will be something that's hard to tell. 1 is going to be 2, so that's going to be right about there. 1.1 I can't really tell. 1.4 I can't really tell. 1.6 I can't really tell. 1.8 is going to be a little under 0.5. right about there. 2 is going to be 0. That's going to be right about there. 2.2 I can't tell. 2.4 I can't. 2.6 I can't. 2.8 is just going to be a little above 0.5, a negative 0.5. So this will be -1. So 2.8 I said? Yeah. So that's going to be a little above 0.5. So somewhere right about there, I think. 3 is going to be 0. 3.2, I can't tell for sure. 3.4 is going to be a little less than 2. So that's somewhere right about there, I'm guessing.
This is some zigzagging kind of graph, ain't it?
No, it's not as bad as it looks. And 3.6 is almost 3.5. Somewhere right there. It's a lot smoother than it seems.
Well, it's like an odd function move to the right a little bit.
Something like that. Not exact, but close. It goes down maybe a little bit further below here. Okay. I don't know how much, but, you know, something about like that. Okay. Now, position of an object moving horizontally on a straight path. Which of the following is true? Little Roman numeral I. Object is, say again?
So I'm probably not going to talk about this.
Okay. The object is accelerating on the interval 0 to 0.6. Okay.
So it's the graph is the slope is positive.
Uh-huh.
So you would think maybe.
The velocity is positive.
Right.
Okay. But since it's concave down, the acceleration is negative. So it's decelerating
It's slowing
down. Exactly.
And then once you get to the next part, it's going to be something.
Okay. So Roman numeral I is accelerating on 0 to 0.6, and that's no. Its velocity is positive there, but acceleration is slightly negative. The greatest velocity is right at 0, and the velocity here is less than 0, so, I mean, it's less than it is at 0, so therefore it's actually decelerating. So Roman numeral 2I. The object has a positive velocity on the interval 1 to 1.4. Here is 1, and 1.4 is there. Yes, a positive velocity, that's correct. That's for sure. Okay?
From 1 to 1.4.
Oh, wait, no, velocity. Okay, sorry about that. No, negative. Wrong. Not that. Velocity. I was doing position. The slope is down, so that's a definitely no. Roman numeral 3I. The object is speeding up on the interval 1 to 1.4. No, that's the same as saying it has a positive velocity. So that's a no.
Well,
Oh, speeding.
yeah, it's accelerating, so the slope is negative. It's going to get about 1, and then it just goes up.
Okay.
What was the ending point on that?
Okay. 1 to 1.4. Here is 1.
Oh, so
And here's 1.4 would be something about there.
Yeah, I don't see that as being.
It is, no, you're right. It is speeding up but in a negative direction. Okay. This is written by a mathematician, not a physicist, so I hope they know what they're talking about. So it could be this one. It's speeding up. Wait, no. Has a negative velocity. Okay, its greatest velocity was here. No. No. The greatest velocity is at the point of somewhere there, here, certainly here and there. Okay, So I think this is a possibility, okay? Roman numeral IV, meaning they need blood, okay. The object is stopped at t equal 2 seconds. No, the object is at 0 position, but it's definitely not stopped. So I think it has to be 3, which is C.
Just out of curiosity.
All right.
I confused. I think I had
Velocity and velocities crossed up.
It depends on the graph. They didn't have their axes labeled.
Right.
They didn't say the x-axis was velocity.
Well, what they said was the graph represents position of an object moving horizontally in a straight path. All right, number 13.
I guess I looked at that more of a physics perspective.
Right. All right.
Less of a math perspective.
And what I want to do is go back here and make that 13.
Reusing the slide.
All right.
And what time do you need to get out of here?
5:15 today.
5:15. Well, we'll stop in 6 minutes.
Okay. Okay, the radius of a sphere is decreasing by 1/4 of an inch each hour.
Oh, this one was weird.
Draw a sphere. Ugly sphere, but a sphere. The radius is decreasing by 1/4 of an inch each hour. So this is dr dt is equal to -1/4. That's what that means, inches per hour. Find the rate of change of the volume of the sphere with respect to time at the instant that the radius is 3 inches. So when r is equal to 3, we want to know the rate of change of volume. That's dv dt. When the radius is at 3 inches, the instant when that is 3 inches.
Okay, so we'll just plug in 3 into the volume of the sphere.
Okay, do this first. V is equal to what?
4/3
Pi r cubed. Got it. Then do this. dv dt is equal to what? dv dr times dr dt. Would you say that's not true? Okay. And this is what we're looking for. dv dr, where we know what dr dt is that. And we can calculate what dv dr is, can't we? That's dv dr is equal to, no, yeah,
Oh, you want to go ahead and do the thing. It'd be 4 pi r squared.
4 pi r squared. Perfect.
They were round, okay.
Second?
I thought they were round.
Yeah, they used to be. Okay, but 4 pi r squared, if you put them in. Okay,
You got to go to the box.
so I think this is just a plug and chug. dv dt is equal to dv dr at the moment that the radius is 3 inches. So that will be, and this is in inches per hour, yeah. So this will be 4 pi times 3 squared. So that would be 36 pi.
Oh, because r equals 30. Sorry. I was plugging in 1/4 for that for some reason.
Okay, that's, yeah, the VD. Oh,
Times.
my R's and my V's look similar.
But aren't we looking for dv dt?
You're looking for dv dt. So this will be 36 pi times dr dt, and dr dt is a -1/4. So this will be negative 9 pi. And that will be cubic inches per hour. And that's B. Bravo.
If I got it, it was yes.
No, you were one to the right. Okay.
I didn't really have a plan of attack for that, so I just
Yeah.
skipped it.
Right.
And then that's one of the, I skipped a bunch.
Right. Okay. All right.
Did the ones I thought I could do.
Right. Want to do 13 or we're out of time?
Yeah, we're pretty much out of time.
Huh?
We're pretty much out of time.
Are we? Okay. So,
We could have been done. 13 out of 40.
yeah,
Of course.
more than we did the others in
We had
that.
an hour and a half to do this test, so.
Yeah. Well, been doing a bit of talking with it too.
Thanks.